this lesson, we are going to continue to talk about correlation and linear regression, but we're going to talk about something that we didn't talk about in the previous videos, which is a t-statistic. So some instructors and homework softwares require you to use a t-statistic to do some of the computations related to this stuff. So this video will walk through another example of correlation and regression, and we're going to learn how to use the t-statistic as well. So t-statistic is a test statistic for correlation. And this test statistic for correlation, t is going to be r over the square root of another fraction, 1 minus the quantity r squared, all over n minus 2, where r is the correlation coefficient, the sample correlation coefficient, just in case I should squeeze that in there, and n is the sample size. All right, so now that we know what t is, we are going to go ahead and do an example, and we're going to use t, or we're going to compute t as part of this example. So listed below are amounts of court income and salaries paid to the town justices. So the income is how much the court brings in, and the salary is paid to the town justice, I believe similar to, if not the same thing as, a judge, potentially a little bit different there. All amounts are in thousands of dollars. So what that means is that for this particular example, the income of the court is $33,000, and the salary of the justice is $18,000. Construct a scatter plot. Find the value of the linear correlation coefficient r, and find the p-value and corresponding t-statistic using a significance level of 0.05. Okay, so now we're told that alpha equals 0.05. That's my significance level. We want to know, is there sufficient evidence to conclude a linear correlation between court income and justice salary? And does it appear that justices might profit by levying larger fines? Finally, we're also going to provide the regression line, and to do all of this, we are going to use www.statdisk.org. Previous videos have shown you how to do these steps. You're going to put your data into the columns. You're going to go for analysis, and I should say into columns. Analysis, and then you're going to grab the correlation and regression option. So to get ahead of things, I have already put our data into StatDisk. So I will copy this, and we'll head over to StatDisk and see that that data is already in there. So you can see the first column starts with 64 and ends with 33. That is the income, and I should mention this is going to be my X variable, my input variable, and then salary is going to be my Y variable, or my output variable. So independent and dependent variables listed there. And we have our Y variables listed as well, 31 in the beginning, 18 at the end. So okay, everything looks good. All right, we'll choose the analysis option up here. Grab analysis. From the drop-down, I select correlation and regression. And it wants to know, where is my data? My X data was in column 1. My Y data was in column 2. If you ever plug them in to different columns, that's okay. Just tell StatDisk which columns they're plugged into. And significance, it's defaulted significance to 0.05, and we had alpha equals 0.05, so we're happy there. What do we need first? Well, first what we're going to get here, I'm going to say let's go ahead first and get R and the p-value first, and then we'll go ahead after that once we have that, and we'll find Let's see, what else do we need? We need t. And while we're here, let's go ahead and find the regression line. Okay, so let's get started with R. Evaluate. There's R. R is 0.85243. Now, generally, homework has you round this. For this particular example, we are not going to round. And the reason is because we're going to need this R later to get T. So I'm not going to round yet. If I need to round, I can. But for now, I'm just going to grab the whole thing, 0.85243. 85243. And how about my p-value? Remember, this is for the hypothesis test. My p-value is 0.00351. Now, I can round this one if I want. I'm going to round to 3 decimal places, so that's 0.004. Why not? 0.004. Now, the other things we need are the t-statistic and the regression line, and then we'll do our hypothesis test. So let me just highlight what we're looking for. Significance level of 0.05, we already got that written down. We need the correlation coefficient R, which we have, the p-value, which we have. We need the t-statistic, and we need the regression line. So we don't have the t-statistic, but we can grab the regression line right now. And that regression line is y hat equals, if you'll recall, b sub 0 plus b sub 1 x. And let's see what b sub 0 and b sub 1 are. B sub 0 is 27.35, etc., etc. Let's round this. You'll follow the instructions for where your homework wants you to round. Let's go ahead and round to 2 decimal places for both of these. Now, your homework could tell you, by the way, that they want you to round it to different decimal places for the intercept and the slope. That's okay. Just to point out, by the way, that the intercept can also be referred to as the constant, and the slope can also be referred to as the coefficient of x. So some homework softwares are going to refer to those way, or that way, pardon me. Okay. All right. So my constant, my y-intercept is 27.35. That's my b sub 0, remember. So that's 27.35 plus b1. b1 is 0.0, we'll round that to 2 decimal places as well. That's 0.04. X. So there is my regression line. Y hat equals 27.35 plus 0.04x. Cool. So regression line is done. At this point, all we need is our t-statistic, and then we'll go ahead and do our test. So let's get this out of the way since we're moving into doing our test. But before we do the test, let's compute the t-statistic. So the t-statistic, remember, t equals, I can recopy the formula, r over the square root of a fraction, and that fraction was 1 minus r squared on top and n minus 2 on bottom. So it looks like I need to know what n is as well. So let's go ahead and copy n down. N equals, remember, n is just the sample size. So I can count 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I can go into StatDisk. StatDisk tells me that the sample size is 9. Okay, good to know. Sample size is 9. So n equals 9. Ah, by the way, the homework problem here also asked for a scatter plot. In previous videos, you've seen how to draw a scatter plot, but if you want a quick visual of that scatter plot, you can get it on StatDisk. Just click on the scatter plot tab. Oops. Looks like I accidentally shifted. Let's go back. Scatter plot. So let's re-evaluate. There we go, scatter plot. There it is. Okay. So there's the visual for your scatter plot. Back to the results, we know that n is 9, and now we're going to compute t. All right, so t, this, by the way, is why I didn't round r. I do not want to round r. I'm just going to grab r exactly the way it is, and I'm going to plug it into this formula for my t-statistic. So we have r equals 0.85243 all over the square root of stuff 1 minus r squared. Don't try to round this. Just plug it in. 0.85243. This quantity and this quantity only gets squared. And this is all over n minus 2. N is 9, so 9 minus 2. All right, now let's go ahead and not do this by hand. I don't want to see what's happening here if I try to do this by hand. I would much rather plug this into a calculator that can do it all at once. And the calculator tool that I prefer here is Desmos. So we're going to round this for Desmos. Now, a lot of homework has you rounding your test statistic to 3 decimal places, so that's what we're going to do here. And I'll show you how to use Desmos as well. By the way, I should just say that Desmos is www.desmos.com. So we go to Desmos. I'm going to use the drop-down Math Tools Scientific Calculator. And here's what I know. I start off with a fraction, so I'm going to type the division. On top, I have my r, 0.85243. And on bottom, I have a square root, so I'll grab that square root tool. Then I'm going to go ahead and just get the fraction ready to go. On top of the fraction is 1 minus r squared. Now I'm pretty lazy. So let's just scroll over that. Just grab r, Control C to copy, click back in, Control V to paste. Cool. And squared, or you can retype it by hand, that's fine as well. That's squared. On the bottom, we had n minus 2. N was 9, so this is 9 minus 2. And there is my t-statistic, 4 point, etc. Now, I want to round this. I'll zoom in so you can see it a little more clearly. I want to round this to 3 decimal places, we said, so that's going to be 4.31. That 3 is going to get bumped up by the 5 to a 4. So 4.314. So that is my test statistic t. Oops. There we go. So we're looking at 4.314. I cannot stress enough, don't try to do this in bits and pieces. Don't try to round, get one piece and then round and then get another piece and then round. Do this all in one go. That's going to be a much better experience for you. This is going to be the best way to get t. So plug it all in at once and then round one time. Okay, what else do we still have to do here? The only thing we have left to do at this point is the hypothesis test. So let's go ahead and do that hypothesis test. Hypothesis tests can be done using the t-statistic. They can be done using critical R values. And if we needed critical R values, by the way, the critical R values were also available in StatDisk. There they are, critical R. That's the plus or minus 0.66, etc. This lesson, though, in a previous lesson, I've shown you how to use those critical R values. In this lesson, I'm just going to show you how to do the more classical hypothesis test. Okay, so finally, we can do the hypothesis test. To do that, I'm going to go ahead and get rid of the data, the raw data, because we don't need the raw data for the hypothesis test. That's gone. What we do need, we don't need t either. We have t, good enough, I can get rid of it. So here's the stuff that I need. I need alpha. This information is what I need. And I can even erase n equals 9. Now remember, for a hypothesis test, we're looking at a null hypothesis and an alternate hypothesis. So that's H sub O and H sub A, null and alternate. Remember that R was a sample statistic. I had that written back here. R is the sample correlation coefficient, and rho, if you'll remember, is the population correlation coefficient. If you'll recall, we said that if R was close to 0, there was no correlation. But if R was close to 1, or if R was close to -1, then there was correlation. So my null hypothesis is going to be that there is no correlation. That rho, we're using rho, not R, but that's okay. Rho equals 0. If R equals 0, there's no correlation. Rho is just the population version of R. And my alternate hypothesis, thankfully, is going to be two-tailed, so we have rho is not equal to 0. The correlation exists. So I'm just going to write that note in there. Rho equals 0 means no correlation. Rho is not equal to 0 means that there is correlation. Now remember, for a classical hypothesis test, if P is low, reject HO. So we're going to have alpha equals 0.05 as my sigma level. My p-value was 0.004. And then I do my hypothesis test. If P is low, well, P is in fact low. P is smaller than 0.05. So since P is low, we're going to reject HO. So with 5% significance, there is evidence to conclude, let's say suggest, there's evidence to suggest correlation, because in HA, that's where we live now because we rejected HO. HA says correlation exists. To suggest correlation between, what are my two variables? My two variables were income and salary. So there is evidence to suggest correlation between court income and justice salary. Now, does this mean that justices might profit from levying larger fines? Well, this means that since R is positive, and I'm going to point this out, since R is positive, that means that when court income goes up, justice salary goes up. It means that when court income goes down, justice salary goes down. So I should go ahead and mention this. If R is positive, we have what's called positive correlation. Which means that when one increases, the other increases. However, if R is negative, this is a negative correlation. Which means that when one goes up, the other goes down. We have here a positive correlation. So it's definitely possible. We would assume that when one goes up, the other would go up, which means that it is possible that justices are going to profit by levying larger fines, right? If one goes up, the other goes up. So it's possible that justices benefit from larger. I want to just point out, by the way, that correlation does not imply causation. Does not imply causation. Meaning that just because two things are correlated doesn't mean that one caused the other to happen. A classical example of this is that in the summer, both crime and ice cream sales increase. That doesn't mean that selling more ice cream leads to more crime, and it doesn't mean that more crimes lead to selling more ice cream. It just means that both happen to increase at the same time. So correlation does not imply causation. What that means here is that there's no reason to assume that justices levying larger fines necessarily guarantees or is what caused the salary increase. But it does indicate that it's possible that one causes the other. So this is an example of doing another correlation regression problem. Again, the big difference here is that in this video, I showed you how to compute the test statistic t, and here it is. Remember, when you're computing this test statistic t, plug it all into a calculator in one go. Don't try to round this nonsense and then compute more and then round again. So at this point, you know how to do lots of different things with correlation and regression. Hopefully this video was helpful.